Alright guys, this video is going to get into igneous rocks. We're going to go over the definition of igneous rocks. We'll talk about the process of crystallization. We'll talk about igneous rock environments, the texture of igneous rocks, and the chemistry and composition. Make sure you take good notes. Going to give you a pop quiz on this material tomorrow in class. If you have any questions at the end, feel free to Edmodo or send me an email. Alright, so what are igneous rocks? Igneous rocks, the word igneous itself means from fire. And what that suggests is this, is that they come from volcanoes. And that's one thing that all igneous rocks have in common, is they all originate from volcanic environments. So how do they turn from magma or lava within a volcano into an igneous rock? It's through a process called crystallization. It's when you take that molten rock, which is just simply melted rocks and minerals. You got to heat it up pretty high, around 1100 degrees Celsius. And you take that melted rock from the volcano and you cool it off. And when you cool it off, it hardens into a solid. Kind of like when you make Jello. When you make Jello, you start out with this liquidy material. You take the warm water and the sugar, mix them together, and then you cool it off, and you get a solid Jello. It's kind of the same thing, where you take this molten rock, it cools off for a period of time, and it turns into a solid rock. Now, where does this happen? Again, it generally happens near volcanoes. So if we have a volcano here, and here's the ground, and here's a tree for reference, this molten rock can exist in a couple different places. Maybe you have molten rock below the surface. Spelled that wrong. Or maybe you have molten rock at the surface. Molten rock below the surface is called magma. And molten rock at the surface is called lava. So maybe you have this molten rock that just kind of oozes out of the volcano here. Well, when it's below the surface, we're going to call it magma. When it's at the surface, we're going to call it lava. It can also be above the surface if it's shooting up into the air. The difference is anytime it's below the ground, we're going to call it magma. If it's at the surface or above, we're going to call it lava. We also call igneous rocks that form below the surface, we call those intrusive. Now, this is no longer molten rock that's below the surface. This stuff here, magma, is exclusively used to describe molten rock that's below the surface. But after that molten rock has cooled and hardened in the process of crystallization, if that happens below the surface of the earth, we're going to call that an intrusive igneous rock. And an igneous rock that forms at the surface from lava, we're going to call that extrusive. So an extrusive igneous rock is one that forms at the surface from lava. Again, it's not molten material at the surface. That's what lava is. But after that lava has crystallized or cooled and hardened into an igneous rock, we call it extrusive. All right, let's talk about the texture of igneous rocks. The texture of igneous rocks refers to the crystal size, or the size of the crystals within that igneous rock. It has nothing to do with feel. This is a big mistake that people always make. That word texture suggests feel. It has nothing to do with it. It doesn't. We're not going to describe these as rough or smooth or bumpy. It has nothing to do with that. It has to do everything with the size of the crystals within the rock. And when we take a look at this guy here, we can see some pretty big crystals here. So here's a big white crystal. Here's a bigger black crystal. There's kind of like a smoky-ish crystal looking over here. Each one of these different colors that we see here are different crystals. And we can see them plainly with the naked eye. And what that means is we don't need any microscope, any magnifying glass to help us out. When we can see crystals, visible crystals with just our eyes, we're going to call that a coarse-grained igneous rock. Here's another one down here. We have some really big crystals hanging out here. And these big crystals are all coarse-grained. These things are big enough to see. without the aid of a microscope or of a magnifying glass. All right, on the opposite side, we have what's called a fine-grained igneous rock. And in a fine-grained igneous rock, the crystals are generally too small to see with the naked eye. So you would need a microscope or you would need a magnifying glass to see these things. And if we also take a look, this one right here is a little bit special in that it has holes all over it. So those holes have names. We're going to call an igneous rock that has a bunch of holes like this, we're going to call it one of two words, either frothy, and what that means, it's kind of like the foam on top of a cappuccino or a hot chocolate, or we're also going to call it vesicular. Vesicular is kind of like a vesicle that maybe you learned about in biology, a little passageway. And if we take a look down here, we have another type of fine-grained igneous rock. This guy here looks like a piece of glass, and we're going to call it glassy. Now again, all three of these, this one down here, the one in the middle, and the one up top, they're all fine-grained. The only difference is this guy has holes, so we're going to give it a special name. We're going to call it frothy or vesicular. And this guy here looks like a piece of glass. It's still fine-grained, but we're going to call it glassy because it has that glassy appearance. All right, last thing, let's talk about the composition of igneous rocks, which refers to the dominant chemistry of the original molten rock. So all this stuff was still magma or lava. It had a dominant chemistry of either being felsic here on the left or mafic here on the right. Let's get into what those mean. Felsic we can break down into two words, fel and sic. And fel stands for feldspar. And sic stands for silicic. And if we remember back, feldspar and silica, or anything silicic, is anything that contains the combination of silicon and oxygen, the two most common elements in the Earth's crust. These are generally lower density rocks, and they also generally have a much lighter color than the mafic rocks. And if we cruise on over and take a look at the mafic side, there's two different words that make this up. Ma from the element magnesium, Mg, magnesium, and fic from the word ferric, which means iron, and there's a chemical symbol for iron. And so what we have here, mafic igneous rocks, are igneous rocks that are very high in metals, such as magnesium and iron. And because of that, they're going to generally have a higher density, and they'll also be a darker color than the felsic igneous rocks. If we take a look here, here is granite, here's a rock called rhyolite, a rock called pumice, much lighter in color than this basalt over here on the right, the scoria, and the gabbro. Now the one exception would be this guy right here. This is a rock that looks mafic. However, its chemical composition is dominantly silicon and oxygen, so it is a felsic igneous rock, and you'll see this one in lab. Now while we're looking at these rocks, let's go ahead and tie a couple things together to wrap up the video. Let's take a look at this granite here on the far left and compare it to this rock, which is called gabbro on the far right. Notice that they're both coarse grained because they both have very big crystals. But this one here is felsic, granite, felsic on the left, and the one on the right here is mafic. So this guy here will have more metal in it, and the one on the left will have less metals, fewer metals. So this one will be a lower density. And if we compare now the one below this granite, this is called pumice, to the one here on the far right, this is called scoria, you're going to see that they're both frothy or vesicular. The two words mean the same thing. The only difference is their chemical composition. Let's go ahead and compare this igneous rock to this igneous rock. Notice that they're both fine-grained. One is felsic, one is mafic. So really, when we talk about igneous rocks, what we're going to have to constantly be aware of is this. Is the rock felsic? Is it mafic? Is it coarse-grained? Is it fine-grained? And we're going to apply this in class with a couple of labs that we have to talk about to help highlight these points. Alright, so in this video we talked about what igneous rocks are. We talked about the process of crystallization and the molten material that goes into it. We talked about intrusive versus extrusive, or the environments from where igneous rocks come from. We talked about the texture of igneous rocks, coarse and fine, frothy, vesicular, and glassy. We also talked about the chemistry or the chemical composition of igneous rocks. That would be mafic and felsic. Mafic being more dense, felsic being less dense. Again, if you have any questions, please bring them into class tomorrow. Get ready for a pop quiz on the basic material, or you can send me a message on Edmodo if you need something cleared up.